Hi, good morning all of you. Today I am going to explain regarding of the density based spatial clustering of application with noise. Nothing but a DBSCAN algorithm. The full form is DBSCAN. Regarding of the DBSCAN algorithm is the density based spatial clustering of application with noise. It's a very good algorithm. It is also used in data mining and warehousing techniques, and also it is used in updated machine learning applications, and it is also used for research purpose also. And while you looking of the different circles are observed here, it will checking the diagram. The core points are there. That means the two circles are joined together, and the touchable point is called the core point, and the border the border point of the particular circle is the border point. The core point is the some of the identification we have shown in the diagram. It is called the core points. The core point is nothing but the center point which is touchable to the both of the circles. The outlier is the noisy points. These noisy points are outside of the circles. That means which are not touchable to the circles. That is a noisy data, which is an irrelevant data. It is not a relevant data. Is the neighborhood and midpoints and core points and border points and noisy points. These are the diagrams. With this particular diagram, we can identify what is the density and what we are identifying the clusters, group of clusters in spatial, and that should be the applications with noisy. Even we considering the with noisy data also. What the partitioning methods we are using of the k-means algorithm also. The historical clustering are suitable for finding spherical shaped clustering. That means the cluster points are joined together. This is in a spherical shape. We have already seen within this particular diagram. I am showing the x and y coordinates. Where some lines together joined and some spherical shape it is there. That is the explanation part I have written here, and that is the diagram. This is the diagram, and this is the explanation part. The finding the spherical shaped clusters. How many spherical shaped are there? A small one is there, and the big one is there, and also the more bigger one is there. That is not a particular circle. It is a spherical shaped. Okay, and in other words, they work well only for compact and well separated clusters. That means those are considering only within that only, not considering the out of the boundary of the particular spherical shape. Those sphericals are considered. That means the compact and well separated clusters are suitable for the separated clusters. That means those are structured in spherical shaped that are separated. Okay, you can check the down one having some straight line. We are observing the dot, and the dots are considering like a straight line. The two straight lines are there. Okay, below the spherical shaped. Moreover, they are also severely affected by the presence of noise and outlier in the data. Suppose these are the peoples who are surrounding here and there in the outside of the area, like a ground we can consider. Some groups are separated due to some dividing of the batches of the particular work they are considering. Suppose the group of people are playing some cricket teams. Each group is separate team. Okay, like in Australia, India, and England. That means we can consider like that. We can. These are the group of different clusters. There is an example of the population, and we can take a good example like a cricket team. We can consider the team considering the 11 members. That means The England team is where, and cricket, every country having a separate cricket team. Suppose all together they are playing an IPL match. They are dividing in a group, like like an IPL match. They are dividing like a group team. All mix it together. They are forming like a 11 members to form a cricket. And in that same manner, here they are particularly spatially they are identifying in a cluster shaped or a spherical shaped clusters. Unfortunately, real life data can contain a clustering of arbitrary shape such as those shown in figure below. Okay, that is a linear and S shape. We can observe in like a in a clear cut way. We can, while you looking the diagram, we can observe the linear means the straight line, and S shape also within, while you are observing the spherical shape, and we can observe the particular S shape also, alphabetical S for S for sun, that means the particular S alphabetical structure is also we can find in the diagram. Okay, the plot above contains the 5 clusters. That means 5 clusters are identified in the diagram. Outlier including 2 vowel clusters, 2 linear clusters, one compact cluster. One compact cluster is that is an S alphabetical shaped, and 2 vowel clusters and 2 linear clusters are there. Okay, and what is the use of the DBSCAN? The goal is to identify the dense regions, that is the density based spatial clustering application with noise here. No? We are identifying the dense regions which can be measured by the number of objects close to the given point. Okay, 2 important parameters are for the DBSCAN, that is an epsilon, EPS, and minimum points. Epsilon points and minimum points are very important for the DBSCAN algorithm. Here some diagrams are there, A and B, A diagram and B diagram. The parameters of the epsilon defines the radius of the neighborhood around a point X. It's called the epsilon neighborhood of the particular X. Okay, the centroid is considered as an X. The centroid point is considered as an X. The parameter minimum points is the minimum number of neighbors within epsilon radius. The radius point between the x2 touchable point of the circle point, it is considered as a radius. The x is the center point and epsilon is nothing but a radius point of the particular circle. The radius is nothing but the half of the diameter. The half of the diameter is nothing but a radius. That is we are considering with the center point to touchable point of the circle. That is called a radius. Radius is nothing but an epsilon point. Here, a minimum points, how many points are there? Like round circles are there, no? Minimum points are 6 in A. And in B, we also, some of the minimum points are also there. Density equal to, this is nothing but a formula we can consider. Density equal to number of points within the specified radius. Density is nothing but a number of points within the specified radius. That means the radius near to the radius only we can consider those are nothing but a density. Those are called nothing but a density points. Those are which are near to the radius. Okay, the number of points within the specified radius only we are considering that those are nothing but a density. What we can consider density? The number of points within the specified radius only we can consider that is considered as a density. Density is nothing but the number of points within the specified radius only. And that means only within the radius only we can consider it is called a density. A point is a core point. It has more than specified number of minimum points within the epsilon. The core point is nothing but simply I am telling that it's a border point, and we can also set that the touchable point to the both of the circles, that is a core point, and we can consider the midpoint of the two circles, that is nothing but touchable point of the edges of the border, that is nothing but a core point. Whatever the core points, border points only we are explaining in the diagram. The border has fewer minimum points within the epsilon, but it is in the neighbor of the core point. The noisy point is any point that is not a core point or a border point. Noise is nothing but the point which is not touchable to the circles. The point which is not touchable to the circles, that is called a noisy point. The noisy point is irrelevant to the data. In border point, core point, those points are relevant to the data. Those are touchable points. Those we can consider even within the radius also, within the specified of the radius also we can consider as a density of the DBSCAN algorithm. Those are the densities we can consider because it is very near to the radius. Okay, and another diagram is also there within a brief manner. What is the core point is the midpoint, outlier is the outer point, epsilon, minimum points is 5. Minimum points is 5 because those are near to the radius. Okay, that's it. You having any doubts means just text me, and please subscribe my channel, Jai Sri Ram Education channel. Thank you all of you. Thank you so much.